The 2025 update of the Muscat missile represents a continuation of one of the most iconic and feared anti-ship weapons ever developed, refined to remain relevant in a rapidly evolving battlefield dominated by advanced sensors, electronic warfare, and layered missile defense systems. Originally designed during the Cold War to counter large naval strike groups, the Muscat has always been about one core idea: overwhelming speed, destructive power, and minimal reaction time for the target. In 2025, this philosophy remains unchanged, but the technology behind it has quietly evolved to meet modern operational realities. At its core, the Muscat missile is still built around the concept of supersonic sea-skimming flight. This flight profile keeps the missile extremely close to the surface of the sea, using the curvature of the earth and background clutter to hide from radar systems until the final moments of the attack. In the 2025 update, improvements in radar altimeter precision and flight control software allowed the missile to maintain an even more stable and lower altitude during terminal approach, reducing detection windows and increasing the probability of a successful hit against well-defended ships. One of the most important areas of modernization in the 2025 Muscat update is guidance and targeting. Earlier versions relied heavily on active radar homing with limited resistance to modern electronic countermeasures. The updated variant introduces a more sophisticated multimode seeker, combining active radar, passive radar detection, and improved inertial navigation with mid-course correction. This allows the missile to operate in heavily jammed environments, switch modes automatically if interference is detected, and continue tracking even if the target attempts radar silence or decoy deployment. Electronic warfare resistance has become a defining feature of the 2025 Muscat. Modern naval vessels are equipped with advanced jamming systems, tow decoys, and soft kill defenses designed specifically to confuse incoming missiles. In response, the updated Muscat integrates adaptive signal processing algorithms that can analyze false targets in real time, prioritize the most credible radar signature, and adjust its attack profile accordingly. This significantly reduces the effectiveness of traditional electronic countermeasures and forces defenders to rely more heavily on hard kill systems. Speed remains the Muscat's most intimidating characteristic. In 2025, refinements to the ramjet propulsion system improve fuel efficiency and thrust consistency, allowing sustained supersonic flight throughout most of the missile's trajectory. While raw top speed figures are not dramatically higher than earlier versions, acceleration during the terminal phase has been optimized, making interception even more difficult. For ship-based air defense systems, this means less time to detect, classify, track, and engage the missile before impact. The warhead of the 2025 Muscat missile continues to emphasize maximum damage against large surface combatants. The high-explosive payload is designed to penetrate ship structures before detonation, ensuring catastrophic internal damage rather than surface-level destruction. Advances in fusing technology allow more precise control over detonation timing, increasing lethality against modern hull designs with reinforced compartments and damage control features. Even heavily armored ships face serious risk from a single successful hit. Launch platform flexibility has also been a key focus of the 2025 update. Traditionally associated with large surface combatants and coastal defense systems, the modernized Muscat is now more seamlessly integrated with the wider range of platforms. Improved interface electronics and standardized launch protocols make it easier to deploy from upgraded naval vessels without extensive structural modifications. This enhances fleet-wide compatibility and reduces logistical complexity for operators. In the context of modern naval warfare, the Muscat is no longer viewed as a standalone silver bullet weapon but as part of a layered strike concept. The 2025 update emphasizes coordinated attacks, where multiple missiles are launched simultaneously or in carefully timed sequences to saturate enemy defenses. Enhanced communication links between missiles allow limited data sharing during flight, enabling dynamic target allocation and reducing redundancy if one missile is intercepted. Survivability against missile defense systems has been another major area of improvement. Modern ships employ advanced phased array radars, rapid reaction interceptors, and close-in weapon systems designed to counter supersonic threats. To address this, the updated MOSCAT incorporates subtle radar cross-section reduction measures and more unpredictable maneuvering patterns during the terminal phase. These evasive maneuvers are calculated in real time, making it harder for defensive systems to maintain a stable firing solution. The 2025 MOSCAT update also reflects lessons learned from recent conflicts and naval exercises around the world. Emphasis has shifted toward reliability, maintainability, and long-term storage performance. Updated materials and corrosion-resistant coatings improve the missile's readiness in harsh maritime environments, while improved onboard diagnostics allow crews to assess missile health quickly before deployment. This ensures higher confidence levels during operational use. From a strategic perspective, the continued modernization of the MOSCAT missile sends a clear message about the enduring importance of anti-ship capabilities in global security dynamics. Despite the rise of stealth aircraft, drones, and cyber warfare, control of the sea remains a critical factor in power projection. The MOSCAT's ability to threaten high-value naval assets forces adversaries to invest heavily in defensive systems, altering fleet composition and operational planning. In 2025, the MOSCAT is increasingly positioned as a deterrence weapon. Its presence alone can influence naval movements, restrict access to contested waters, and complicate amphibious operations. Even advanced carrier strike groups must account for the risk posed by modernized supersonic anti-ship missiles, adjusting routes, formations, and defensive postures accordingly. This strategic impact often outweighs actual combat use. Another notable aspect of the 2025 update is improved integration with modern command and control networks. While the missile itself remains largely autonomous once launched, pre-launch targeting data can now be sourced from a wider array of sensors, including maritime patrol aircraft, satellites, and coastal radar systems. This network-centric approach enhances targeting accuracy and expands engagement options beyond traditional line-of-sight constraints. Training and simulation have also benefited from the modernization program. Updated digital twins of the MOSCAT missile allow crews to practice launch procedures and engagement scenarios in highly realistic virtual environments. This reduces training costs, improves readiness, and minimizes the need for live-fire exercises, which are expensive and politically sensitive. Despite these upgrades, the MOSCAT missile retains its distinctive design philosophy. It is not optimized for stealth in the same way as newer subsonic cruise missiles, nor does it rely on extreme maneuverability alone. Instead, it combines raw speed, low-altitude flight, and heavy destructive power into a package that remains uniquely challenging to counter. In a world of increasingly complex defense systems, simplicity paired with performance can still be a powerful approach. The 2025 update also reflects a balance between modernization and cost-effectiveness. Rather than developing an entirely new missile from scratch, incremental upgrades extend the service life of an existing platform with proven combat credibility. This approach allows operators to maintain a credible anti-ship capability without the financial and technical risks associated with completely new designs. Looking ahead, the MOSCAT missile's role is likely to continue evolving. While hypersonic weapons and unmanned systems attract much attention, the modernized MOSCAT demonstrates that supersonic anti-ship missiles remain highly relevant. Its 2025 update ensures compatibility with current threats while preserving the characteristics that made it famous in the first place. In conclusion, the 2025 MOSCAT missile update represents a thoughtful evolution of a legendary weapon system. By enhancing guidance, electronic warfare resistance, propulsion efficiency, and integration with modern platforms, it remains a serious challenge for even the most advanced naval defenses. The MOSCAT's continued presence underscores a simple truth of naval warfare: speed, power, and smart design can remain effective across generations when continuously adapted to changing technological landscapes.